Okay, this will be a nice short one here. As it says on the screen here, we're going to do some extra info. You can see it's only 4 more slides, nothing bad here. Extra info. There are reactions that form gases, and there's a couple of chemicals that you have to know about that are going to behave in very specific ways. And these are really, really good things for you to know about. So reactions forming gases, and then how do we write net ionic equations for those? Okay, so these are actually some acid reactions that we're going to talk about, but it's something that really needs to be discussed before we even really get into acid-base reactions anyway. So it says here, just read with me, certain salts, for instance, carbonates, sulfides, and sulfites, will produce a secondary gaseous product when they react with acids. Ooh. So see, it's actually a salt and an acid. For instance, if you take sodium carbonate, Na2CO3, and react it with acid, HCl, which is hydrochloric acid, first take a moment to pause the video and write the products of this reaction. Hopefully you wrote this, sodium chloride and H2CO3. So you have carbonic acid, H2CO3. Well, here's the problem. Oh no. This is a normal double displacement reaction, obviously, but carbonic acid is actually unstable. And when this compound is formed in aqueous solution, it will break down further. And this is what will happen. So here's the reaction we just talked about. But this H2CO3, this carbonic acid, will actually break down into H2O and CO2. In other words, water and carbon dioxide. And that makes this H2CO3 compound considered an intermediate, something that is produced only for a short period of time, and then it breaks down into more stable products. So your final reaction for the reaction of sodium carbonate with hydrochloric acid would look like the last thing that you see on the screen here. 2 NaCl plus liquid water and carbon dioxide gas. You would be required to take this to a full net ionic form, which means that the sodium carbonate, the HCl, and the NaCl all are broken into ions. So notice what I've done so far is I've actually taken out my spectators, kind of doing this step a little bit in my head, recognizing that if it's balanced, my sodiums will cancel, my chlorines will cancel, and it will actually leave me with a final net ionic equation of the carbonate ion, the 2 hydrogen ions, and that produces water and carbon dioxide. If you feel the need to go back to actually do out the complete ionic equation and then to prove to yourself that you would get this final net ionic equation, please feel free to pause and actually do that. But as a side note, if you've ever wondered what carbonation was in pop or really any carbonated beverage of any sort, even if it's a juice or even if it's actually like wines and beers, it's actually carbonic acid that's forming, and then it's breaking down into water and carbon dioxide. So this is a really significant reaction just in terms of everyday reality. If you drink anything carbonated, this is what's happening in the beverage. So ta-da, science. Okay, so really important. Next slide. You need to make a note card of this. You have to know these 3 reactions. They have to be ingrained in your head. If you have carbonates and you do the reaction that we just showed, in fact, it's right here. You can see your full reaction, meaning that this H2CO2, I'm sorry, H2O and CO2, that's the production of the breakdown of the intermediate carbonic acid. Well, the sulfite ion is going to act the same way. So notice the way that this equation works, which is exactly the same, but here we produce H2O and SO2, because what we would have actually produced would have been sulfurous acid, H2SO3. So the production, when you produce carbonic, H2CO3, or when you produce sulfurous, H2SO3, you have to recognize that those 2 acids are going to be intermediates, and they break down into either H2O CO2 or H2SO2. Finally, this one's a little different. The sulfite ion, when it is in the H2S form, as you see right here, it's a gas. It's not an intermediate. It's nothing you have to break down, but you have to know that H2S is a gas all the time. So if you need to, for a moment, study these reactions and recognize with the previous example what we're talking about, especially with the sulfite reaction, and then see if that can make sense to you, and then we'll do an example on the next slide. Okay, so maybe if there's any questions at this point, to be clear about what we're saying, if you have carbonate reacting and if you produce H2CO3, which is carbonic acid, the H2CO3 will break down into H2O and CO2. If you have sulfite in the reaction and you produce H2SO3 or sulfuric acid, that will break down into H2 and SO2. Okay, notice again the use of the liquid and the gas as the phase diagrams for these two chemicals. And then finally, if I'm reacting a sulfide, which is again just an SO2 negative, or I'm sorry, just an S2 negative. Let me say that one more time. If you're using a sulfide, that's just S2 negative. If you produce hydrogen sulfide, there is no intermediate. It's just that you make the H2S part, and that's a gas, and you have to know that that's a gas. Okay, so hopefully that clears it up just a little bit. And then we're going to go on to an example. So I'm asking you to please try this. You're supposed to complete the reaction and write the net ionic equation. So you have calcium carbonate and you have nitric acid HNO3. So please do me a favor and see if you can, as I ask, complete the reaction and then write the net ionic equation. All right, so hopefully you came up with these two chemicals here as your initial double displacement prediction. So the calcium nitrate and then H2CO3 or carbonic acid. Well, that's a problem because carbonic acid will break down into H2O and CO2. The calcium nitrate stays the way it is. So basically just kind of crossing off the whole initial double displacement prediction that we made, recognizing that we're going to break down the intermediate compound and form H2O and CO2. And then what I have here, this would be the actual net ionic equation. So remember, you only break down things that are aqueous, meaning that the solid calcium carbonate that I started with and that the water and the carbon dioxide, being that those are liquids and gases, I do not break those down. And I will only break down the nitric acid and the calcium nitrate. Take a note on the way that I handle these ions. So again, especially here, the nitrate, notice the 2 behind it, and here's that 2 to show 2 ions of nitrate with only that 1 ion of calcium. And so again, you take a look at this. This is your complete ionic equation. And now we want to cancel out spectators. So what spectators do you see? Hey, me too, nitrate, out of there. And that leaves us with our final answer, which would be solid calcium carbonate reacts with 2 ions of hydrogen. And that's going to produce calcium ions, water, and carbon dioxide. And that's all she wrote. So write down your questions. We'll talk about them tomorrow.